You should be looking at chapter 2, types of variables. Is that what we were saying? Right, so let's look at the homework. You remember last time we set up data and the different kinds of data. So you had categorical data, people's colors, are you in favor, strongly in favor, so, definitely against, things like that. So categorical data, oh, we don't want the solutions. Make that go away. Give me a second. Seeing the answers is a big distraction, actually, in my opinion. Right. So we talked about categorical data. Yeah, that's good. No, it isn't. I've still got a heading to get rid of. I think that's a good now. So categorical, it can either be ordinal or not ordinal. It's also called nominal. And categorical data that is ordinal has some kind of order to it. So remember we did example like sophomore and junior and senior. That would be an example of it. If you were giving an opinion from hated it to neutral to really like it, that's called a Likert scale. That's an example of nominal. If it was just colors, are you a male or a female? Your favorite TV programs, what political party you're going to vote for. Those don't have any particular order, right? Male doesn't come before or after female. Republican doesn't come after or before socialists, liberals, or any other party, right? And the other kind was quantitative, and it was continuous or discrete. Remember the continuous or discrete? Ashton, can you remember how you decided between the two? You gave an interesting way of looking at it.
What was this for exactly?
Yeah, continuous and not continuous. The numbers.
Oh, yeah, something that's not continuous, you're only allowed to pick specific values between different things you're given. Categorical, or not sorry. Continuous is anything that is you can pick any value between 2 points.
Right.
So it kind of mangled that sentence.
Yeah, I know, but the gist of it made sense, and I got it. So continuous data, you can pick any number is possible. When it's not continuous, which is also called discrete, so you'll see it in different textbooks called discrete, you can only pick specific values. So a lot of these questions are going to be really quick because you get 5 shots, and since there's only 2 choices, you're probably going to get them right at least after the second shot. But for experience and practice, let's do it. For the following variables, indicate whether the variable is categorical or quantitative. The weight of a woman measured in pounds, quantitative, agreed? Now, if they wanted to go into more detail, would you agree that that's also continuous? Not that they asked us to do that, but isn't a weight a continuous variable? Right, you can be 202 pounds or 202.222 pounds, right? You could be any number you like. Question 3. For each of these, indicate whether it's ordinal or not. And if it is not ordinal, indicate its variable type. Okay. Your opinion on a new tax law, and you're either for it or against it. Which one of those 3 choices describes the variable? The first, the second, or the third?
The second?
Yes. Would you agree that being in favour or opposed, I don't think there's a natural order to that. Can't you say favour, then opposed, opposed, then favour? I don't think there's any natural first, then second going on there, so that's why I would choose that one. You get a grade in your class in statistics. You get an A, a B, a C, a D, and whatever. What kind of data is that from the 3 choices that are in front of us?
Ordinal?
Yes. Would you agree? It's not numbers, right? It's A's and B's, even though they may have numbers hidden inside them. And I think A, B, C is a natural order. Would you agree that most people would order things in some kind of list like that? The height of men, I would think that one is the third one. Would you agree it's quantitative? Is it continuous or not?
I would say it's continuous, but it is in inches in the parentheses. So is that
Ye-
distinguishing? It's got to be 10, 11, 12, or could it be
I
10.3?
don't know. I just think that's the way that they're describing. You could be measured in feet and meters and centimeters. It's just saying that's the way it's measured. It's more of a distraction than a help by telling you that. And in general, anything that has a weight or a length to it is continuous, because can't you measure weights and lengths to as much accuracy as you possibly could think of? So these are very similar questions, so I won't do those. Okay, we got that thing. I'll come back to that. Let's pick one of these. A patient is getting a rating of the pain felt on one day after a surgical procedure, and this one is on a 7-point scale from 1 to 7. And so you can imagine 1, nah, don't feel anything, to 7, cut the thing off, please, I'm dying, you know, or whatever. What is that data? Which one of those 3 choices is it?
Ordinal.
Agreed. Right. Side issue here. Do you know that pain is very subjective? Now, what I mean by that, you can inflict the same amount of physical pain on someone, right? So you can take a pin and you can make sure that this machine just pokes it the same distance in the same part of the arm as another person, right? So you can make everything the same, but can't 2 people feel pain differently? Right? Some people are very susceptible to pain, I guess is the word I'm looking for, right? They feel pain quite easily, and other people don't feel it so much, right?
I think that's called a pain tolerance, right?
Yeah, pain tolerance, right? So because it is so subjective, do you see why they give people numbers? But anyway, my background to this story is, do you know that when you do it with really small children and you're trying to get a feeling of how much pain they're in, it's very hard for children to express things like that easily. So what they do in doctor's offices for very young children is they give them a scale, but it's not 1 to 7. They have pictures of like the faces of children, right? Little caricature pictures from dead happy, right? Because you don't feel any pain. And the one at the end is crying with a really sad looking face. And they say to the kid, point at the picture that you feel most like. And that's their way of getting the doctor getting an idea of how much pain a child is in, right? Because if they're only in the middle, they kind of pick one of the pictures that's, you know, slightly discomforting. It's kind of a cool way of doing it. So you can imagine, how else could you say to a little 3-year-old, how much pain are you in? Because they can't really describe, you know, in English, things like that, yeah. But they can do it visually. They can say, that picture there is kind of how I feel. And that gives them a good idea. Another useless piece of information, but if you're into medicine, you might see that one day. A very short question. Continuous or not continuous? How many coins you've got in your pocket?
Not continuous.
Right? Would you agree that everybody here has a number starting at 0 and finishing at who knows how many coins you've got? But none of you have got 2.5. No, you're not allowed to cut a coin in half to prove me wrong. You've got 2 coins in your pocket, or you've got 3, right? That's the rules of the game.
What if you're in debt? Then it's negative.
I guess, but it's not a coin in your pocket then, or a lack of coins. Right, we haven't talked about that yet, so I don't want to yet. let's look at this story. For each of the following situations reported in the news, specify what the variables are measured. And it could be categorical, ordinal, quantitative, whatever. And it says select all that apply. So it may be more than one thing gets checked off. So the Los Angeles Times survey found that 60% of 1,515 adult Californians that they asked supported a law banning smoking in bars. Okay. Whether a person supports smoking or ban or not is a categorical variable. Would you say that is a categorical variable?
Yes.
Yeah. Do you like smoking in bars? No. Yeah, I'm okay with that. Right. So I'm checking that one. The percentage of Californian bars affected by a ban.
Yes.
Yeah. Now, isn't it a number?
It is. It's
Right.
not what the poll is asking, but it's true.
Yes. Yes. Whether a person reads the Los Angeles Times or not. Is
Also,
that
yes.
categorical? That's a categorical. Whether a person reads the Los Angeles Times is an ordinal variable.
No.
The number of bars affected by this ban.
Yes.
Whether a person supports it or not, no. Do you see in that particular example? I mean, it wasn't all about the thing, but the basic part at the top was correct, and then they went into other places. Do you see in this case there are 4 check marks?
Professor Robertson.
Yes.
Would you? I actually did that problem before, and only one of those should be checked on the top.
Oh.
Because we don't have all those variables because it's not asking that. Those don't show up anywhere.
Huh. I don't like that answer. I like mine. It was better.
Yeah.
Yeah. Okay. Oh, we haven't done explanatory yet.
Okay. I think it's because there is no output or input for those. Right.
I think they were being to the letter of the law. Right. I'll leave that guy with the fact that I got the last one wrong, but I guess you'll find that out when you do it. Sometimes they put a whole load of crosses next to it and tell me I'm wrong. I still like my answer to what I believe the question was. So, according to what I believe the question was, my answer is correct.
Think of it like an equation, what goes in, what comes out, and that's what we're looking at.
Yeah, that's a good analogy. So, we're going to look at a new term. It is on, yes, explanatory variable. And response variable, which kind of leads to what I was saying here. You're going to have, you're going to collect information where there's 2 pieces of information. There's a kind of the question itself, and then the answer the person gives you. So let's suppose we collected data on the age of a child. And for each child, not only did we record the age of that child, but we then measured what their height was. Then this would be the explanatory variable. And that would be the response. So we got their age, and then we got their height. Now, if you switch places, I guess they would change over. Suppose we collected data on the value of a car. So we went to a whole load of people and says, how much is your car worth? And then we found out also what the age of that car was. In this case, that would be your explanatory variable, and this would be your response. Now, one of the ways to visualize this is that if you wanted to represent this information, and so along here, you might have the value, and vertically, you might have the age. The x-axis is very often the explanatory variable, and that the y-axis is the other. And I'm just going to pretend I know what these are. Can you imagine you collected data on various cars, and each one of these dots represents one of your answers. So that car there, right, was worth 1,000. God, that's horrible data. Can I change that data to be more realistic?
Another way of looking at these is the response is like what happened, and the explanatory is why it happened. So in this case, the car's age is because of, it would be, for this one, the height of a child is because of their age for the very first one.
Yeah, and if you switch places, the age of a child would be responsible for their height. Right, this one is more realistic. If you took this guy here, his car is worth 1,000 and it's 10 years old. This guy here, his car is maybe worth, I don't know, 15,000. Can you imagine that's where that was? And his car is only 1 year old. Would it make sense that expensive cars are probably, in general, not always, going to be younger, right? If I'm buying if my car's going to cost me 40,000, that's probably most of the time going to be a pretty young car. If I'm going to be able to buy a car for 1,000, isn't there a good chance it's a banger, 15 years old or something, right? So, explanatory variable, response. The age, the value of a car is directly affecting what its age is likely to be. But it's not a perfect straight line, right? You wouldn't expect that. In fact, you might get a weird answer, like you might get a car that's way up there. Now, how could you get a car that's worth 15,000 and is 15 years old?
A vintage car.
Yeah, or some really expensive Rolls Royce kind of car that even, at 15 years old is still worth quite a lot of money, right? In fact, a funny thing, do you notice that as cars get older, right, if I switch the data around and we do age against what they're worth, their value, don't you buy a car and it's brand new and it's quite expensive, and doesn't it kind of drift downwards? If you keep a car for 10 years, won't it be worth very little compared to what you paid for it? And that's quite common. But here's the clever thing. Do you know if you keep a car long enough, won't its price go up again? Isn't a 100-year-old Ford T Ford, whatever you call them, do you know those things? And they're worth a lot of money. So I guess the moral of this story is, if you look after your car really well and you can keep it moving for 50 plus years, you'll probably get your money back. Right? It'll probably be worth what you paid for it right at the start. So just to show you, x-axis is essentially what we call the explanatory variable. What happens with that is your response. So let's see if we can do these questions. In almost every question, the answers are kind of silly. And what do I mean by that? Well, almost every question, the first thing they mention is the explanatory, and the second thing they mention is the response. So let's pick one of these. I'm on this one. According to AP, 1998 at least, smokers are twice as likely as lifelong non-smokers to get Alzheimer's or other forms of dementia. And they followed this number of people and women, and from this explain the explanatory variable. And what we've got, the explanatory variable is whether they were a smoker, which is categorical. And I don't think it's ordinal, because smoker or not smoker, who's to say what's first and what's second? And the response was whether you developed dementia, and that is also just categorical, because getting dementia or not, I don't think there's an order to it. So you can see it's kind of the first guy is explanatory, the second guy, in this case, smokers, dementia, right? Smokers, yes or no, dementia, yes or no. Don't know what I'm picking here. I'll do one more of these. To answer the following questions, researchers would measure two variables for each individual unit in the study. In each case, specify the two variables, the variable type, and explanatory and response. For college students, is there a relationship between GPA and the number of hours spent? The explanatory variable is GVA. Right, GPA. 3.2, 3.7. Yes.
I already did this one also.
And
that should be number of hours studying.
oh, they switched it.
Because like I was saying before, you get a good GPA because you study. You can just say it out
Study
like
for a
that.
good GPA. Gotcha.
Yeah, like
right.
that.
So number of hours studied. What kind of data is that? Yeah.
Quantitative.
Gotcha. So switch it places. Got the other thing. There's a GPA. Is it quantitative? Yes. Could it be categorical?
So it was correct to say quantitative when I did
Yes.
it. I feel like it should be ordinal though.
Yeah, I was thinking the same.
Because it's in order, but there's no. Well, I mean, I guess there is decimal
There
point.
is.
So you
I
can't
think
get
there
like,
is. Yeah, the reason they went quantitative is that it does have a numerical thing. You know, if you get a 95%, I guess you get 4.0, right? And if you get an 82%, you get 3 point something. So the GPAs are connected to numbers. But I could argue it was ordinal as
actually,
well.
our GPA does go to 2 decimal points, I think, on our transcripts.
Yes, so it is numbers. So I think you could get away with it. But you could argue it was ordinal. Do you know if you give people A, Bs, and Cs, isn't it now ordinal? Because it's a letter, not a number. Right? Because A might represent a whole range of values. So that would be the argument I would give for that. And we are now about to start something new. So be on the lookout for them switching them round like that last one. I get caught on that. So what I'm going to show you now is really just taking information and calculating percentages from it. So what we have here is some categorical data, and it is put into a table format. And I'm going to make up my own question because I feel like doing that. And we're going to do political party and frequency. And you don't know this because I've decided that this is going to be it, but there is a Royalist Party in America, and if there's not, then I've now created it, and I'm a member of it. And the Royalist Party wants America to join Britain again and make the Queen head of state and get rid of the president. Right, so that's the royalists for you. We can have Republicans, we can have the Democrats, and I need one more. Give me
Libertarian.
Say that again.
It's called libertarian. They're
libertarian,
not Republican
yes.
or liberal, or
Right.
or
Libertarian. Right. And we collected data, and 350 people would vote royalist, 110 are Republican, 90 of them are Democrat, and 50 of them are Libertarian. Now, it's a pretend place in America, and this is what we got, right? So I don't think I can offend anybody with this table, except people who are anti-royalists. So the kind of question you're going to be asked are pretty straightforward. They involve calculator, and they involve you finding percentages. So they might, for instance, ask you, what percentage of people are royalists? Now, don't overthink this one. I'll have to add this up. So it's 100, 150, 200, 500, 600. So they probably won't tell you the total. So that you're going to figure out yourself. Now, the percentage who are royalists are 350 out of 600. And to convert something into percentage is times 100. Can you remember doing those fine percentage questions from, oh God, years ago probably? So on my calculator, 350, oops, turn it on. 350 divided by 600 times 100, and let's say that the answers has to be to one decimal place, 58.3%. Are we good with it? Right, now I'm going to add another column. And this is called the relative frequency. And the relative frequency is the percentage written as a decimal. So 58.3 becomes that. So let me get the other ones out the way. If you wanted to do the percentage who are Republican, it's 110 divided by 600. Oops, didn't mean to do that.
Is that so that if we didn't know the amount individually, we could just calculate it from the total and the relative frequency?
You could. Sometimes it's just easier to compare different groups. So I went to town A and this is what I got, and I went to town B and this is what I got, but town A might have twice as many people. And so it's hard to compare. But if you turn them into percentages, or as they do relative frequencies, you can say, yeah, there's about the same percentage of royalists in both, or no, there's a lot more royalists in the first place and not in the second. The next one is 90 divided by 600, and that's a nice 15. So I guess to 3 decimal places, it's that guy. And the last one is 50 divided by 600, and that ends up being a 0.083. And what we've created
would
here
work well on a bar graph. So if it goes
would.
y is 0 to 1, then if you were to add up all the little bars, they would reach 1.
Yeah. So what you just said, let's show you what he's getting at. If you take all of these relative frequencies, they should add up to 1. The fact that this one adds up to, I think, 0.999 was caused by rounding off. But that's okay. That can happen. Now, if you have a table like this, you can describe it as a frequency table, which is that. You can describe it as a relative frequency table, which would be this. And that's one way of visually trying to show people what the data is like. You can, however, create a bar graph. And let me show you what it would look like by hand. And you go like this. And along here, you put whatever the political party is. And if I was going to do a bar graph using this data, wouldn't you have to use a scale, you know, like 50, 100, 150, 200, all the way up? If I wanted to use a relative frequency scale, wouldn't I do a 0, 0.1, 0.2, 0.3, all the way up to 0.5? I don't want to do both. Do you want me to do a frequency or a relative frequency bar graph?
Relative frequency.
Okay, so since the biggest number is 0.583, how about 0.1, 0.2, 0.3?
You can also say it's 0 to 100%.
Well, we wouldn't really be
Makes it
calling
looks pretty.
It looks pretty, but we wouldn't be calling that a relative frequency anymore if we did that. So when you do relative frequency, you kind of have to use the decimals. Now, what you then do is royalist. So you do a little mark here, a little mark here, and you got to put what you think 0.583 is. So I'm saying it's about here. Leave a little space. Republicans 0.183, which is about here. And I guess I should have royalists, Republican, leave a little space. Democrats about 0.15, not much difference, they're about there. And the poor libertarians, they're about here. And you've basically got your bar chart. Now, sometimes people shade it. This visually is a little bit easier to see. Numbers tend to be just a little bit distracting for human beings. Bar charts are quite useful. And what makes a bar chart different from a histogram? Do you notice that there's spaces here? A histogram wouldn't have spaces, the rectangles would be stuck right next to each other. A more obvious difference is that very often in a bar graph, won't these things not necessarily be numbers, but are more likely to be colors, political parties, favorite TV program or something that involves words. Now, the cool thing is that although I did that by hand, and there's no reason why you couldn't do it by hand, there is a nice piece of software, which I'm about to show you, that does it for you. So here is a question where they collected data on 2,511 students. So that's what the total is. And these are 12th grade students, and they went and asked them about seatbelt usage. They never wore a seatbelt. They always wore one, and so on and so forth. So it's kind of like our scale, right? There's 5 on that. Can you imagine calculating all the percentages? Now, draw a bar graph of this data. Well, here's the clever trick. If you hit use salt, right, this will appear in a few seconds. Now, if I go to charts and graphs and I select where's seatbelt, and then I choose, where are we?
You'll want a histogram here.
Yes, I'll hit my histogram. Oh, I don't have a histogram. I should have a box plot, not dot plot, scar plot. I know where it is. There it is. It's at the end. There. You see, it's already drawn the thing for me. And then what can I do? Well, if I go back to the original question, hopefully I can do that without going all over the place. No, darn it in space. Give me a few seconds to kick this in. Well, once I did it, I could then go back and where's our class? There we go. I can't remember what picture it was, but can we, oops, Can we pretend that after I saw it, I paid attention and tried to at least remember what it was? And
It was all increasing going left to or from left to right.
okay, so it made it this one then, right? So it'd be that one. So it's kind of, isn't it kind of helpful that you don't actually need to draw your own bar charts if you don't want to? If that salt button is there, you can do it. Here's another similar example.
Once you find which chart you're using, if you mouse over it, it shows you the percentage values. So you can input that up there instead of calculating.
Oh no, not
can.
allowed. Yes, don't do it.
I didn't do it, but
don't do it. Right. The reason why they have this is that these are accessible. And so when they make them accessible, people who can't see very well can use a screen reader. And so that when their mouse pointer goes over that, it tells them everything that's going on. So it describes the thing. Will you not look at that, please, go and do it the right way, because you're going to get a test from me. And the test I'm going to actually do on PDFs. So that you'll have to do the working. And so it's a good idea to know how to do it, right? Rather than just take the shortcut. We should do something vaguely interesting. Oh, this is interesting data. Right. They've collected, this is question 18. This table gives the age distribution for mothers in a certain country and when they had their first child. The first one was from 2006 and the second one is from 2018. This is actually very realistic data because I've seen stuff similar to this. Now, it is categorical data, and the reason for that is, do you notice that the data is grouped? Right. So these happen to have numbers in them, but couldn't we just say young mothers, slightly older mothers, old mothers, and so on and so forth? Right? You could put other labels on them. So just because you see numbers doesn't mean it's quantitative. It is still categorical data. And these are the percentages in that group. Now, in 2006, 21% of them were under 20 when they had their first baby. And only 7.5% were 35 or over. In the year 2018, it has changed quite a lot. I think the major change that I see isn't the number of young people having their baby reduced a lot. Right. Used to be 20%, right? 1 in 5 mothers had their baby before they were 20, right? Their first baby. Now it's like 1 in 10. Isn't that half as many? And that's a socio-economic thing that's happened in most Western countries. Women do not typically have their children as young as they used to, right? Because a lot of you are interested in having a career. And isn't that the years where you're probably going to be going to college and university or whatever your thing is and getting your career started and getting your qualifications? And having starting your family might make that more awkward. I'm not saying it's impossible because I know it's not, but that's one of the major decisions. Sometimes it's financial as well. You know, a child costs a lot of money. And so you might want to wait until you've got, you know, you and your partner have got a lot more money. So you wait a bit longer. Quite interesting, that data. Less obvious, but it's also true. Aren't some women waiting quite late now to have the first child? In 2006, it was only about 7.5%. I wouldn't say it's double, but it is significantly more. There are other data that you can look at that is very interesting. Do you know the number of children that women have has, in the Western societies at least, has decreased? Your parents probably had more children than you're going to have. And your grandparents probably would have more children than your parents had.
I have 10 siblings, so I agree.
You're going to have less than 10 when you decide to have a family. I hear you, right? And that is a socio-economic thing as well. In the past, you needed lots of children. No, needed, but you typically would have lots of children because a lot of them would die in infancy. Right? We're talking, 150 years ago, right? A lot would die in infancy. And when you got older, didn't you need children to look after you? Because you couldn't afford to work anymore. In a lot of societies, having children is your social security. Because when you get older, you go and live with one of them and they look after you. So it would be, but today we don't need that right, as much. I'm not saying we don't use it. It's quite interesting data. I like it. It's good data. Since you've got 4 pictures, you could probably look at this data, couldn't you, and figure out which one of these 4 was the 2006. I may have to shrink this a little bit, so let's put that as a challenge. And Ashton, I'm giving you the not doing it job, right? So you're going to watch this one and agree. You ready? So from this data here, which one of these would be the bar chart for 2006? 1, 2, 3, 4. Which one would it be? Two, I agree. Somebody did fingers, David, that'll do. I'm picking that one too. I'm going to do a double check on it in case there's another one, but I like this one. Okay, why are you picking that one, David?
I mean, it matches the data. You just got to look at.
That's the short answer. It matches the data. Agree. Yeah. That'll do. Do you know all I did is I looked at the first one. Isn't the first one 21.5? And so I said, nope, that ain't 21.5. Nope, that ain't 21.5. Nope, that ain't 21.5. Yes, that is 21.5, or at least it's the only one that looks like it is. And so I picked it. So you do not overthink these questions, right? You just look at them and hopefully one of them is more obvious than the others, although I've been known to screw up. And here's the data for the other ones.
I just realized those ones also give the values when you mouse
over
it, and the very first one was that.
Yeah. We're trying not to do that. Okay. I think I've got time. Yes, we do. I have time to
say hi in the chat.
Why don't you say hi while I'm setting that up? Yes. I want to try and see if I can do this last question down here before we call it a day. What we've got here is the information, kind of written as a big long sentence. And we're going to take this information, we're going to put it into this table, or at least we're going to try to, and hopefully it'll work. A sample of college students was asked how they felt about their weight. Of the 140 self-identified women in the sample who responded, 32 felt they were overweight. 98 felt, yeah, I feel about right. And 10 of them felt that they were actually underweight. And then 77 self-identified men. 16 of them said, I think I'm fat. I'm paraphrasing this. 40 of them said, I think I'm great. And 21 of them said, I think I'm skinny. Now, see from this data, although it's only 6 numbers, we could collect quite a lot of quite interesting comparisons. If I'm just looking at the data and it's just raw data, but I can convert it into percentages. And the reason why I needed to convert it into percentages, isn't there a lot more women than men in this survey? So I have to factor that in. So what would be better is to find out what percentage of women thought they were overweight, what percentage of women thought they were right, and what percentage were underweight. And that would make the comparison easier. But I can still make that comparison, I think, pretty easily. Here's my first thing that I've noticed. When you look at the overweight women and the men, right? These two here. Let's figure out what that looks like as a total, as a percentage. So if I add that up, that's 120, 130, 140. Okay, so 32 divided by 140, oops. 32 divided by 140. That's about, I'm making very rough rounding off here. That 32 is the same thing as roughly 23%. So 23% of self-identified women. On the other hand, how many men? It was 77 men. So 16 divided by 77. The answer here is 21%. Now, it's not a big difference, but would you agree that women tend to self-identify as being a little bit more overweight than men? They think they're more overweight. I'm not saying they are. They could well be actually perfectly normal weight, but in today's society, women have to be built like sticks because that's what models look like, right? Which are totally unrealistic. Let's look at the underweight. Right, if you do the women, it's 10 out of 140. So only about 7% of women think that they're actually skinny, and they would prefer to be a bit heavier. And men, 21 divided by 77 is 27%. I think that is much more significant, isn't it? So all to do with society and image, why do you think so many men think that they're underweight? Why do guys think they're underweight, or so more than women think they're underweight?
The same reason as women think they're overweight, because of
Stereotypes.
They need to be beefier. That's the image.
That's it. Guys should be hunky, right? Evidently. Which means I should be gorgeous because I'm really hunky. No, I'm quite fat. Yeah, it's social and it's cultural. Do you know that in certain cultures, having more weight is considered attractive? So that in those cultures, if you did the same analysis, those percentages would shift quite differently. Right? So that the idea of what is the stereotypical beautiful version of a person is very culturally orientated. Right? How heavy should you be depends on which culture you're in. Right? In some cultures, certain things are considered more attractive than others. And it's changed through history. Do you know in the past, plumper women, I don't know, that's probably not a nice way of describing it, were considered much more attractive than less plump women. And that was because plump women was a sign of healthiness. You were able to produce children and could probably look after yourself. Whereas skinny women would be considered unhealthy and less likely to produce healthy children. You see how things can change through history?